This project is about the capillary rise of water in between a glass wedge for different opening angles. So first, let's talk about capillary action in general. Let's consider a liquid phase and a vapor phase, like water and air. If there exists a pressure difference, delta P, in between the liquid and the vapor phase, the pressure difference will act as a driving force for the liquid to either climb up the surface or being depressed. This pressure difference is also the reason that the interface between the liquid and the vapor phase is deformed. So it forms a liquid meniscus in between both phases. The governing equation that describes this behavior of the liquid meniscus, which relates the curvature to the pressure difference, is given by the Laplace equation. Here, gamma LV describes the surface free energy of the interface between the liquid and the vapor phase, which is also called the surface tension of the liquid. And the curvature of the liquid meniscus is described by the two main radii of the liquid meniscus. So there is like the radius R1 and R2, whereas R1 is in the plane and R2 is perpendicular to R1, so it's out of plane, describes the out of plane curvature. So the overall curvature of the liquid meniscus depends on the pressure difference. So if we have a positive pressure difference, then we talk about a convex meniscus, and if the pressure difference is negative, we will have a concave meniscus. Now the capillary rise depends on one, on the liquid, and second, on the solid that we're using and its geometry. And so far we talked about the capillary rise in a tube or in between parallel horizontal plates. Note that for both geometries we have either a constant diameter of the tube or a constant distance of the plates. But how does the meniscus look like when we actually change this distance in between those two plates? So if we have an angle in between them. So exactly this will be the purpose of this project. So we want to use a glass plate, form a wedge, and insert that into water. And then we want to see how does the capillary rise change, first of all, over the length of the plates, and then also how does it depend if we change the opening angle of those two plates. So we want to learn how to derive this theoretically, and then we want to verify our theory and back it up with our experimental data. In order to do this experiment at home, you will need a couple things in order to get started. So first of all, in order to form the glass wedge, you will need two glass plates, and I used picture frames that were available. Then you will need a spacer, and I thought it was very convenient to use a glass tube. In order to secure your wedge on one side, you will also need two clippers and a rubber band, which is optional. Then of course you also need cleaning supplies in order to get all this grease off these plates. So you need dish soap, alcohol swab, a sponge, and a towel. And as far as the liquid goes, you need a clear tub that is big enough to fit your glass plates in. So I used tap water in order to make it visible. I used food coloring, red, yellow, and green, and I mixed it all together. That's why it looked so brown. But you can use pretty much any color you want. So now in order to visualize the capillary rise qualitatively, I also made a little scale. So I just used a ruler, protractor, a water-resistant Sharpie, and a clear foil to make the scale. So once you gathered all the materials, we can pretty much get started with the experiment. So first, we want to make sure that both glass plates are cleaned thoroughly, because we want to make sure that we have a free path for the water column to rise on our glass plates and that we don't have any impurities on it. So you want to go ahead and use the dish soap to get rid of all the grease and fingerprints on the glass plates or little fibers. And then you want to rinse off the dish soap with water, and also make sure that you dry off the water with a towel. So, and to ensure that there's no water markings on the plate, I also used an alcohol swab, and just wherever the water column is going to be, I just like wiped it off a little bit. So the second step is preparing our wedge with the glass plates that we just cleaned. So you want to put them on top of each other and then open them at a certain angle and secure one side of the glass plates, the glass wedge, with the clamps, with the metal clamps. And then on the other side, in order to make sure that it doesn't close, I'm just going to put the glass tube in it and use it as a spacer. So here you can see that you can also use a rubber band in order to make sure that the spacer doesn't fall out during experiment. And then the spacer you can kind of move forward and backwards in order to change the opening angle. And the opening angle you can measure with a protractor in order to make sure you have the data. Step number 3 is making a scale in order to get a quantitative, qualitative analysis of like how high your water has risen in terms of the opening angle. So here you want to just use your clear foil and draw a coordinate system on it with the height, the capillary height on the y-axis and the width of the plate on the x-axis. And then you want to attach the scale to your glass wedge. In order to prepare the liquid, you just pretty much have to fill the tub with the tap water. I use tap water. You can also use distilled water if you want to get maybe better results. But I just had tap water. And then you want to mix in food colors. Any colors are allowed. Do whatever you feel like. And then the next step would be inserting the wedge into the water. Ta-da! This is so cool. You can almost instantly see the water rising up the glass wedge. Fascinating.